Okay. So we talked about these things: sample statistic, population parameter, sample statistic, we calculate, population parameters, we estimate. So why we go for sample data without going for population data? We are going for sample data because of three reasons. One is it will be a costly process, you need more time and you need more labor. So due to that reason, we go for sample. Right. So then we have another one, that is, now here we are talking about classification of data depending basically on how it is presented, right? So how the data set is given. So we can classify the data set according to how it is presented. So now see, suppose you have a sales data like this. So here the values are given as it is. So if the values are given as it is, so we call it as discrete type data. So if the just values are given, so you call it a discrete type data. Now sometimes the same data, if you want, you can identify what is the value, how many times it is repeated. So here marks. 2 students got 4 marks. 3 students got 5 marks. So here the marks or the value and the corresponding frequency, how many times it is repeated, given. So single pieces. So if the observed values are single pieces and if the with the corresponding frequencies are given, you call it a frequency data. And the third one is, we can classify the observed values. We can classify the observed values in range, right? So 180 to 185, 185 to 90, 190 to 95. So how many? What is the frequency? So if the data set is given in this format, then you call it a group data. So why are we classifying this way? Because the central tendency as well as measures of dispersion formula depends on how the data is classified in this pattern. So for this discrete type, you have a formula. For frequency type, you have another formula, and group type, you have another formula, right? So by looking at the data set, you can add, okay, this is discrete, this is frequency. So the difference between these two is, here the observed values are single pieces. Here the observed values are single. Okay. The three types of data. So we'll know from that. According to the way the data set is presented, according to the way the data set is presented, according to the way the data set is presented, we can classify, according to the way the data set is presented, we can classify the data, we can classify the data, we can classify the data into three types. We can classify the data into three types. We can classify the data into three types. Discrete, frequency, and group. So with the example, you can write down. So these numbers are not important. You just put your values. It's okay, fine. You can include your values if you want. Discrete, frequency, group. 180, 185, 185, 190, 90, 95, 95, 200, so it goes like that. The number of employees, yesterday I said 41, 57, 27. So group. Okay, so we don't have any issues with this discrete type and frequency type, but group type we have issues. So we'll just look at some examples. Now here you are given a data set. So just carefully look at this data set. Oh, I'll put all the things. So 3 data sets are there. So just look at the data set. All are group data. So when you look at this data set, what do you feel? Do you feel, okay, it is given in the correct form or there is something wrong? If you feel something wrong, due to what reason you feel that it is wrong? Just check. So this is data set 1, 2, 3. 3 different data sets. So what do you feel? Which one you feel correct like and which one you feel not correct? If you feel it is not correct, due to what reason you feel not correct? What about the first one? What do you feel? Is it correct or you feel it's not correct? If so, due to what reason you feel not correct? Data set 1. Yes. Whatever you feel, it's okay. I don't want the correct answer. So if you feel it's not correct, okay, due to what reason you feel not correct? Or do you feel it's correct? And one, third one. So first one, I'm having an issue like this. If one student has 20 marks, right? If one student has if one student has 20 marks, where should it go? 20 marks. Because here we have 15 to 20, 20 to 24. So that 20 marks where should go? I have that issue. Right? Okay. So likewise, when you look at this data set, do you feel okay, this is something wrong, like so due to what reason? That's what I want. Third one. Okay, so due to what reason you feel it's not correct? Okay, the same reason is there. Apart from that, other than width, right? One is to 0 to 10, other one is 10 to 25, so the gap is 15. Right? So the first, sorry, the gap is 10, first fifth, gap is 20, 15, first gap is 10. So the gaps are not the same. So gaps we have issue. Right? So borders we have issue. Right? Border issue is there. Gap is issue is there. Right? Then what about this one? This one you feel correct? I feel correct. Okay, so this is correct. Okay, so that's how you feel. So let's say now this one, if you take, right, so this issue is there. Now in all the classes, right, all the classes, if you look at, the end point of one class becomes the starting point of the next class, right? End point of one class is the starting point of the next class. So that means the classes are connected. Here the classes are connected. Here also the classes are connected. Right? End point of one class becomes the starting point of the next class. So classes are connected. Here it is not connected. So what you have here are connected classes. Connected classes. There also you have connected classes. And here unconnected. Unconnected classes. Right. So in the connected classes, right? In the connected classes, if you take if you take one particular class, right? One particular class, if you take, it is of the form A to B, right? So A to B form, right? 5 to 10, 10 to 15. So A to B form. So in the connected classes, if you take this particular class, A and B are two values. So if you take the class A to B, this class will contain from A up to B, not B. B will be going into the next class. So if you take, say, for example, if you take this class will contain from 5 up to 10, not 10. 10 will be going into the next class, right? So that border issue is now okay, right? So now we have another issue. Suppose in this case, one student scored 35 marks. One student is having the maximum 35 marks. Now where to put him? If we say this A to B contains from A up to B, not B. If a student scored 35 marks, where should he go? So according to the way we define, he cannot be included in this class. 30 to 35 should contain from 30 up to 35, not 35. So then we have to create another class like 35 to 40 or something, right? So only for a single value, no point in defining another class. So in the connected classes, except the last class, all the other classes will follow this from A up to B, not B. But the last class will contain both the borders from 30 up to 35 with 35. So the last class will contain both the borders, right? So then that issue is rectified. So that's how it is developed, right? All the classes are from A up to B, not B. The last class will be containing both the borders. So this is no problem. That data set is okay. And the class widths are the same, equal class widths and also connected. So now this one. So that the border problem is sorted out, right? So that's okay. Now the gap. Now there is no rule that all the classes should have the same width. Right? So when developing a group data, there is no rule that all the classes should have the same width. When we develop, yes, we develop that way, then it will look nice and handling the data set is easy. So that is that is why we develop equal class widths. Otherwise, there is no rule that we should have the same class width. Now, say suppose you have something like suppose you have developed a class like say 10 to 20, 20 to 30, 30 to 40, you have developed nicely with all the class widths to be the same. 50 to 60, it goes on. Okay, this is the frequencies here. This frequency is 100, this frequency is say 10, this frequency is 5, this frequency is 2, and this frequency is 150. So now when you have a data set like this, now if you look at the frequencies, this is having a frequency of 100, this is having a frequency of 150 and so on. But these classes are having very small frequencies. So sometimes one or two of these classes may have zero frequency also. So in such cases, with these hundreds and 150s, no point in keeping these 10, 5, and 2, right? So in that case, what we can do, we can combine these two and just make it a 3-class data set, like 10 to 20. So there is no rule that we should have the same thing. We can have different class widths. It's okay, it's fine. Right. So this is okay. This is okay. Ah, very difficult to do. Easy. So now we'll come to this one. Right. So now, as you said, right, this is perfect, no issue with this. But the problem here is, if all the observations, if all the observations are full figure observations, and if all the observations are full figure observation, we can develop the data set in this format. Right. So now say, for example, you can have 30, right? 30 observation 30. So then it will go into this. Another observation 31. In full figure. Now suppose if you have decimal values like 30.3. In the original data set, you have 30.3. Or you have say 50.1. Now 30.3, do we have a place to put that 30.3 in this data set? We have the 21 up to 30 is there. From 30 to 31, there is a gap. 31 to 40 we have. So 30.3, we can't put in this data set. Similarly, 50.1, we can't put in this data set. So you can develop the group data in this format if you don't have decimal figures in the original data set. Then yes, this is okay. Right? So if you have decimals, then you have to go for this connected type of data set, either this format or maybe that format. Okay, so all the three are correct. Only this one we can't use when the original figures are decimal figures. Okay? Otherwise, all are perfect. So saying that, now we'll move on to central tendency. Right, so that's much. Right. So now those are the preliminary things we want to discuss. So what is a population? What is a sample? And what are the types of data according to the way it is presented? And group type, in what forms we can have the correct group data, right? Okay. So now measures of central tendency. So measures of central tendency means what? Now say we are given 3 values like 5, 10, and 15. We asked to find the average. The only average we know is we add the three values, divide by 3, you get the average. That is what we know as average. But in statistics, average has a broader meaning. So there are different types of averages defined. There are different types of averages defined in statistics. So measures of central tendency means types of averages defined in statistics. Types of averages defined in statistics. So why we need different types of averages? Now say you have some sales figures. You have some sales figures. Say monthly sales figures. You want to find the average monthly sales. Then in that case, you can add all the sales. You can divide by the number of months, you get the answer. It's fine. That's a good value. But now say you have another instance like you have a moving vehicle with different speeds. So it accelerates, decelerates, or you have a moving vehicle and you are measuring the speed of that vehicle at different points. You are measuring the speed of that vehicle at different points. And you want to find the average speed of that vehicle. Average speed of that vehicle. So in that case, by adding all these speeds, dividing by the number of points you have collected the data, won't give you a good measurement for the average speed. Right? So similarly, now say rates, interest rate. First year 15%, second year 13%, third year 12%, fourth year 16% per annum. So first year, second year, third year, fourth year. So those are the interest rate. Now you want to find the average interest rate. So by adding all these and dividing by 4 won't give you the correct answer. So you have to use a different type of average. So that's why for different scenarios, we need to use different types of averages. So that's why in statistics, several types of averages are defined. So there is nothing called the best. Some are good for some purpose, right? So there are different ones. So this is good for this one. This is good for that one. So that part you get from experience. Which average should be used for this scenario? Which average should be used for this scenario? Scenario comes from experience. Okay, right. So I take down. Measures of central tendency. So that's the topic. Measures of central tendency. Measures of central tendency. Measures of central tendency. Measures of central tendency. So that take down this page. Types of averages defined in statistics. Types of averages defined in statistics are called measures of central tendency. Types of averages defined in statistics are called measures of central tendency. So here we have the full picture. So here this is not visible. Here what we have is averages. Here averages. So these averages you can classify into 2 categories, right? The types of averages you can classify into 2 categories. Mathematical averages and positional averages. Under mathematical average, we define the mean. There are different types of means defined. We have the arithmetic mean, weighted arithmetic mean, geometric mean, harmonic mean. And under positional averages, we have two averages defined. One is the median and the other one is the mode. Right. So that's the full picture of central tendency. Averages classified into two categories: mathematical averages, positional averages. Under mathematical average, we define the mean. Different types of means are defined: arithmetic, weighted arithmetic, geometric, and harmonic. Under positional, we have the median, we have the. So short form, this arithmetic mean we can denote as AM, arithmetic mean, AM. Weighted arithmetic mean, WAM, weighted arithmetic mean. Geometric mean we can denote by GM. Harmonic mean we can denote by HM. Arithmetic, weighted arithmetic, geometric, harmonic. Okay. So this is why I meant, okay, different types of means are defined for different scenarios. So for business purpose, arithmetic mean would do. And also we use weighted arithmetic mean. Now if you take this share price index, so that's a weighted arithmetic mean. Weighted arithmetic. So if you want to find the average rate, geometric mean. So under positional, we have the median and mode. So according to the syllabus, we will be discussing the arithmetic mean in detail. So I gave you all this that you have to have an idea that other than this arithmetic mean, there are some more, right? There are some more. You have to have that idea. So central tendency means types of averages defined in statistics. Averages can be classified into two, mathematical and positional. Under this, we have the mean, different types of means defined. So now we'll go into this arithmetic mean in detail. Arithmetic mean. Okay. So we said we can have the population data, we can have the sample data. So if the population data is available, we can calculate the population mean. If the sample data is available, we can calculate the sample mean. So we need two different notation because we should be able to identify, okay, this is population mean, this is sample mean. So for population mean, we use the notation mu. So we write mu like this. So this is mu. So mu denotes the population mean. X bar denotes the sample mean. So this is sample mean. X bar. You read this as X bar. This is mu. So mu you write like this. Mu. So this should be written in this way. If you write the other way around, this is something else. That is eta. That is different. So mu. So according to the given data set, we have to identify whether we have the population data or a sample data, and accordingly we have to use the notation, whether it is mu or whether it is x bar. Okay. So now the formula for this x bar and mu. Now see, before going into that, we said we can have population data, we can have sample data. So population data, right? Most of the time we don't get, but still there is a chance of getting population data. Population data we can have sample data. Then we said, according to the way it is presented, we can classify into three types: discrete, frequency, group. So, two types here, population sample. So, we can have population discrete type. We can have sample discrete type data. We can have population frequency type. We can have sample frequency type. We can have population group. We can have population sample group. So all together, you have 6 categories now. So you have 6 categories: population discrete type, sample discrete type, population frequency, sample frequency, population group, sample group. So there are 6 cells. For each one, we have a formula, right? If it is population discrete type, one formula. So 6 formulas should be there. So next we look at the formula. So I'll write down it. Population discrete frequency group. So discrete, population discrete type. Population means, so it is mu equals sigma A over N. Okay, so this is that normal sigma notation, right? So what you write like this, the sigma. I used to write like this, right? So this is the same sigma. Right? Sigma. If we have sample, if you have sample discrete type, sample mean is X bar equals sigma X over. Now, formula wise, if you look at, both are the same. Here we are using simple N, here we are using capital N. Right? So that is because sample is small when compared to population. So that's why we use capital N and simple N, but formula wise, both are same. You add everything, you divide by the number of people. Then population frequency. Population frequency. Mu equals sigma fx over sigma f. Sigma fx over sigma f. And if you have sample frequency type, x bar equals sigma fx over sigma. So finally, population group mu equals sigma fm over sigma f. X bar sigma fm over sigma f. So here M means class midpoint. So I don't have space here. So I'll write this M over there. So this M means class midpoint. Class midpoint. M is class midpoint. So now everything is available, all the formula available. Now, when you are given a data set, you have to identify first whether it is a population data or a sample data. Then, by looking at the data set, you can identify whether it is discrete frequency or group type. Then you can pick the correct formula, apply, get the answer. That's it. Right. So very. So now I'll take some examples and see how we can do the calculation. I will take the first example. So no need to take down the answer to that. Surely can down with it. The number of ATM transactions per day were recorded at 15 locations in a large city. The data were 35, 49, 225, blah, 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 all the values are there. Find the mean number of transactions. Find the mean number of transactions. So first we have to identify whether it is a population data or a sample data. So what do you think? It is a population data or sample data? Sample. If you can't identify, just take it as sample. If it is specifically mentioned as population data only, you have to use that. Otherwise, always it will be sample. So this is a sample data, 1 day. So sample data. So, and what is the type? Is it frequency, group, or discrete? Just values given. So first type, discrete. So this is a sample discrete type data. So now in your table, you can identify the formula. So here we have the formula. So we have to use this formula and get the. So X bar, first example, X bar equals sigma X sigma X over N. So sigma X, what we have to do, we have to add all those values. So here we have 35, 49 to 25. Add all those values, we add up to 60. And there are 15 pieces. So we have to divide by 35, 49 to 25. The last one is 60 divided by 50. So when you add all these values, you are getting 1189 over 15. We can. Okay, so you need a scientific calculator for this course. Maybe any type. So earlier I used to recommend a model, but now I am not because that is very costly. So you can buy any scientific calculator. So maybe Casio would be preferred because that is easy for handling rather than that citizen calculators. So Casio would be preferred. Then it's easy, right? User friendly. Okay. So how much are you? 76, 79 point something. 30. 79.2. Okay. Okay. So now in statistics, formula given, data set given, we got the calculator. So we can calculate anything. So after calculating, we have to say what we have calculated. So what is this 79.27? We have to say. So now what is this? What these values are? These are the number of transactions per day. So we added all the 15 location transactions and we divided by the total number of locations. So what we get here is the number of, so this is average number of transactions per day at an ATM. That is what we have calculated. Average number of transactions per day at an ATM. So we should be able to calculate. After calculating, we should be able to interpret the value or say what does it mean. So now we'll take an example. This is what we discussed earlier. So that's the second example. So find the mean of the following frequency data. So this is also the I know problem sheet, the second problem, right? Number of employees absent and number of days. Right. So now the data set observed values are single values with the number of days. So this is a frequency type data also given. Now we have to identify whether this is a population data or sample data. Nothing is given. So we treat this as a sample data and it should be a sample data. Because only for 22 days we have the data. So it's a sample data. So if it is a sample data, sample frequency type data. So if it is a sample frequency type data, then the formula we use is X bar equals sigma fx over sigma. So now we have to identify which one is the frequency and which one is the observed value. Number of employees absent, number of days. So this is our observed value. This is our frequency. Now we need this sigma fx. Whatever the sigmas you need, the corresponding column we have to develop. Other one is sigma f column is already there. So we need to develop the fx column. So one more column we develop. So 2 into 2, 4, 12, again 12, 20, 18, 21, 24. So now we need this total, fx total. So we add all this. So here we get 8, 8, 16, 16, 20, 21. So this is 111. And we need the sigma f, 9, 12, 12 and 8, 20, 22. This is 20. So 111 over 22. Then 11. Sigma is 22. If you divide 111 by 22, you get a lengthy long answer. So we say you get 5.0454545. It goes like that. So if you restrict to 2 decimal place, it is 5.05. So now we have calculated the value. We have to say what does this mean. So what is this 5.05? Number of employees absent, number of days. We divided the total number of employees absent by the total number of days. So what we get here is the average number of employees absent per day. So this is average number of employees absent per day. Average number of employees absent per day. average number of employees absent. So we calculated, yeah, incomplete. So now, suppose you have a data set of this type. Number of trees, number of apples. Suppose you are given a data set, number of trees, number of apples. You have the values here. You are asked to find the average of this data set. So we have to identify which one is the observed value and which one is the frequency. So how do we identify which one is X and which one is Y? Number of trees, number of apples. So which one is X, which one is Y? F. Number of trees is X. Okay. Then number of apples is F. Right. So okay, doesn't matter, we will take that way. So this is X and this is F. Right. So we have the formula, so we can calculate the X bar. Then finally, we will be explaining this X bar. So if we take this as our X and this as our F, how we will be explaining our X bar? Average number of, our X is number of trees, so average number of trees per, we will dividing by the total frequency, so total number of apples, so average number of trees per apple. That's what we get if we take X and F this way, right? So then you have to say, okay, is this okay? Then I'm going to take the other way around, right? And check what you get. Whatever the one which sounds good, you take that way. So if this is my F and if this is my X, I will be again calculating the X bar. So how am I going to explain my X bar? Average number of apples per tree, right? Average number of apples per tree. Okay, so out of these two, this sounds good, this sounds good. So we take this way. So sometimes it is difficult to identify which one is your X and which one is your F. In that case, okay, say, okay, if I take this way, how am I going to explain my X bar? Both ways you check, whatever the one which sounds good, take it that. Okay, right. So this is possible. This type of instances may arise. So take that way, look at it, and then decide. Okay. Right. Okay. The mean of the group data. So they don't say anything, just group data. They say we don't know whether it is a population data or sample data. No clue. So we take this as a sample data. Sample group type. So if it is sample group type, then which formula we use to get the average? X bar equals sigma Fm over sigma. So first of all, we need to get the M value, class midpoints, M. So how do we get the M? Class lower limit and class upper limit you add, divide by 2. Class lower limit, class upper limit you add, divide by 2. So 10 plus 30, 10 plus 30 divided by 2, which is 20. So likewise, 30 plus 50 divided by 2, 40. 50, 60 divided by 2, so that is 55, 65, 80. So we have the class midpoints, M values available. But for the formula, we need FM, product sum. So next we create FM column. 5 into 20, 100. 7 into 40, 280. 550. This is 25, 30, 32. 15 into 8. So 0, 0. 0, 40, 8, 30. And 600. You add all these, get sigma FM. You add all these, sigma F. So substitute in the formula. Get that. So this is weekly wages. So we better go up to 2 decimal place according to what you use. You have to decide whether 1 decimal or 2 decimal or what, because this is a money value. So you better go up to 2 decimal place properly rounded. So you get the value. Then we need to explain what this means. This average weekly wage employee average weekly wage per employee. Try to calculate the value. You need the sum sigma F. This is your F. These are your FM values 100, 280, 550, 325, 1300, 600. You have. That's your sigma FM. Substitute. So what's the final answer? I will calculate. 63.65. So that many, if you want, you can include that many. So whatever the problems we discussed now, up to now are direct problems. So now we'll take some indirect problems. So data set given, we found the average, right? And now question number 7. So here, find out the missing value of the variate in the following distribution. X value is given, corresponding frequency is given. One value is missing here. Mean value given 31.87. So they are asking us, okay, you find this value, the missing value. Mean given. So the values I want to copy is 12, 20, 27, 33, missing value, so take as X, 54, another one is 8, 16, 48, 90, 30, value is given 31.8. So rather than keeping this way, if we put it in the column form, then it's easy for us to do the working. So we'll say like X and frequency. 12, 20, 27, 33. The missing value will take as X, 54. Then the frequency is 8, 16, 48, 90, 30. So now this is a frequency type data, must be a sample data. So what formula they would have used to calculate the X bar? X bar is given as 31.87. What formula they would have used to get the X bar? Sigma fx over sigma. So we'll calculate the values. Fx. Calculate. And this. Here we get 320. This value you can get. This value you can get. This is not a value. 30 times x. So we put it here. 30x. This value you can get. All these values are real values. And this is an expression. But we need sigma fx. So sigma fx would be the addition of all these values plus that 30x. Then we can get this sigma f. So we can add this. Now this x bar is given 31.87. Sigma fx. Now we have the expression, the total of these values plus this 30x. So we have the value. So we can substitute that here. So as it is, I'll substitute plus 30x over this 200. Now this is the value. This is the value. This is a value. So now you can cross multiply, take this to the other side, divide by 30. So there it's not a direct problem. When x bar value given, we asked to find a missing value. So if you calculate your x value, the missing value, here you are getting some 5,114 or something like that. 5,114, right? This is 200. Right, so the values are there. Now we can substitute. It is 5140 is 200. Cross multiply, take this to the other side, divide by 30. So next we'll take question number 8. So question number 8 says the average rainfall of a city from Monday to Saturday is 0.3 inches. Due to heavy rainfall on Sunday, the average rainfall for the week increased to 0.5 inches. What was the rainfall on Sunday? So Monday to Saturday, average rainfall given. Monday to Sunday, average rainfall given. They are asking us what was the rainfall on Sunday. So Monday to Saturday, 0.3 inches. Monday to Sunday, 0.5 inches. What was the rainfall on Sunday? So Monday to Saturday, average rainfall given, average 0.3 inches. Monday to Sunday, average 0.5. So Monday to Saturday, 6 days. Monday to Sunday, 7 days. So the 6-day average will say X bar 6. I'm just using notation, that's all, right? 6-day average 0.3. 7-day average X bar 7.5. How they would have calculated the 6-day average X bar 6? How they would have calculated X bar? Sigma X 6 divided by 6. So total rainfall on the first 6 days divided by 6 would have given them X bar 6. Right? Monday to Saturday, total rainfall divided by 6. So this value given 0.3. So that is sigma X 6 over. So we can cross multiply 1.3, sorry, 1.8. So this implies sigma X 6 inches. What is that? That is the first 6 days total rainfall. So now similarly, we go for the other one. X bar 7. How they would have calculated X bar 7? So they would have calculated like sigma X 7 divided by 7. This value given 0.5. sigma x 7 divided by 7 cross multiply. So that gives us sigma x 7 is 3.5. Now what is this? 7-day total rainfall, 6-day total rainfall. Get the difference, you get the 7th day. Six-day total rainfall. So this is 7-day period. Sunday rainfall. Sunday rainfall. As sigma x 7 minus sigma x 6. 3.5 minus 1.8. So that is right here 1.7. So Sunday rainfall is that. So these are just to make the things easy. I'm just using some notation. That's it, right? Sigma x, it means 6-day total rainfall. That is 7-day total rainfall divided by 7. So question number 9 is a missing value problem, something similar to what we discussed. This is a normal problem, direct problem. Calculate the arithmetic average. Arithmetic average means the mean, normal mean. Same thing, right? For a frequency data, the mean frequency data. This is a good one. Question number 12. I hope you have completed the video one. You want that? This one you need still. So we'll take question number 12. So they are asking us something, but the data given is something else. Actually, 50 students took up a test. Okay. The result of those who pass the test is given below. So the data set is of the students who pass the exam. If the average mark for all the 50 students were 5.16, find the average mark of the students who failed. Students who passed, marks is given, data given. They are asking for the average marks of the students who failed. Just think how we can get. All together there were 50 students. Result of the students passed given. Average mark of all the 50 students given. They are asking us the average of the students who failed. The data, let's let me copy the data. Five, six, 7, 8, 9, 6, 4, 3. The average of all the students, 50 students, so it is 50. Average is given. X bar is 5.6. That's all given. So the average of all the 50 students given, average of all the 50 students given. So we'll use notation like X bar 50, all the students. Now I will put it like X bar all. X bar all the students given 5.16. So now we are given this data, that is students who passed. Data set. Marks and the number of students. Five, 6, 7, 8, 9. Okay. 8 here, 10, 9, 6, 4. So mark, this is our X, okay, and this is our F. So 8 students got 4 marks, 10 students got 5 marks, 9 students got 6 marks, and so on. So these are the students who have passed. So we can develop the effects column. We can develop the effects column. 32, 50, 54, 42, 32, 27. So now we can find this sigma fx. So here 11, 15, 17, 1, 3, 6, 10, 20, 23. Now similarly, we can get this sigma f. 7, 13, 22, 32, 40. Now, what is this data set? This is the students who passed. How many students passed? 40 students passed. What is their total marks? 237. So 40 students passed. 40 students passed. So that implies how many failed altogether? 50 were there. So 10 students failed. So total marks of students passed is 237. So now this X bar all. How they would have calculated this X bar all? Sigma fx over sigma f. Sigma fx all over sigma f all the students. Sum of the marks of all the students divided by the total number of students. So this value given 5.16. So sigma fx all. Sigma f all, number of students who sit for the exam, 50 given. So this is 50. Cross multiply. So we get sigma fx, total marks of all the students, 5.16 into 50. 516 divided by 2. So total marks of all the students, 258. Total marks of the students failed is, student pass is 237. So we can get the gap. So that is the marks of the students fail. How many students fail? 10 students. So 21 over 10. 258, So 21 gap. Okay. X bar fail. Sigma fx fail over sigma f fail. 258 minus 237 over 50 minus 40. So how we got each value is there, right here and there because of the space problem. So that's the big problem. This one, mean normal direct problem. Missing value. So next we'll take question number 15. So that's a problem like the mean is calculated. After some time, they realize that there is a mistake in the calculation. One value is taken in a wrong way. So they are asking us to get the correct average. So what we are provided with is the wrong mean. So it's it. Mean of 20 values is 45. So the average is 45. If one of these values is to be taken as 64, taken as 64, let me see, taken as 64 instead of 46, find the correct mean. So X bar calculated. X bar calculated, but it is the wrong value. X bar, wrong value. I'm using W to say wrong value. X bar W. What is it? 45. 20 values. So N is 20. So that is correct. 25. Then one of these values is to be taken as 64 instead of 46. So which one is the correct value? One of these values is to be taken as 64 instead of 46. So they have taken it as 46. So this is the wrong value. This is the correct. This is taken for the correct. Now we have to include this correct value and get the corrected mean. Right. So we have the X bar wrong value. X bar wrong value. So why this is wrong? Because the sum is wrong. We have the wrong sum. And we have divided that by 20 because it is 20. So this wrong value given 45. So sigma X wrong value 20. Cross multiply. So you get sigma X W. The wrong sum is 900. Right? Wrong value is 900. Now we want the correct value. So to get the correct value, X bar correct. What we need? We need the correct sum. Correct sum divided by 20 would give us the correct mean because 20 is not there. So now the issue is how to get this corrected value. So sigma X correct value. We have the wrong value, wrong sum. So from the wrong sum, we remove the wrongly entered value and add the correct value. Then we get the correct. From the wrong sum, you remove the wrongly entered value and you put the correct value there. So the wrong value already found as 900 minus 46 plus 60. Now you can get this value. After getting this value, it's just a matter of plugging in the value. Get the correct. Right? So wrong value given. From that, we found the wrong sum. We identified how we get the correct mean. For that, we need the correct sum. How can we get the correct sum? From the wrong sum, we remove the wrongly entered value and we add the correct. So we get the correct sum. You can substitute. question number 16. Right, so I'm picking here and there. So after doing all those problems, then you can do the rest of the part because it has some the type is the stage, right? So 16. The average monthly sales for the first 11 months of a year of a certain salesman were 12,000. But due to his illness in the last month, the average sales for the whole year came down to 11,375. What was the value of his sales during the last month? Okay, so first 11 month average given 12,000. For the entire year, it is 11,375. So they are asking us what is the last month sale? So what are the things given? What are we asked to find? So January to November. Jan to November, the average given 12,000. Then January to December, the average given 11,375. So they are asking us the last month, December sale. So what are the things given? Month average X bar 11. 11-month average given 12,000. Then 12-month average given X bar 12 given 11,375. How they would have calculated the 11-month average? So X bar 11 they would have calculated like the first 11-month total sales divided by 11. So this 11-month average given 12,000. So sigma x 11 over. So we can cross multiply. So we get sigma x 11 is 12,000 into the value. So this is first 11-month total sales. Then how they would have calculated the entire year average? X bar 12, they would have calculated like sigma x 12, the entire 12-month total sales divided by 12. So this X bar 12 is given 11,375. So that is equivalent to sigma x 12 over. So from this we can find the total 12-month total sales. So sigma x 11,375 into 12. So this gives us 11-month total sales. This gives us 12-month total sales. If we get the difference, we get the 12-month sales. 11 month total sales. 12 month. Sales. 12 month sales plus what? Sigma x 12 minus sigma x 11. Get the values. 12 month sales. Sigma x 12 minus sigma x 11. 12 month total sales minus 11 month. We have those values here. Substitute. So I have covered almost all the types you have here. So this is again the correct mean, wrong mean given, correct mean they are asking us to find. Combine mean. So now you can try up to question number 20. Right, so up to 20, whatever the problems we didn't discuss, you can. So we have done similar types. So I hope you can do those problems. So if you are finding it difficult in any problem, you can. So for that, you have to try. Okay, so with that, we'll wind up the class for the day. So sorry about that technical part. After some time, it came okay. I gave you this thing for timing, right? Ah, okay, okay. Yeah. You can keep motion. Yeah, we will be. I will tell you next. Ah, yeah, yeah. Kilo 70, so it depends, right? Kilo 70. Anyway, you'll be getting it. Maybe at least 4 or 5 months over. Yeah, with me, I'm also waiting for say from 2:30 today. Yeah, we can start. So if you are okay, then it's okay with me. If I don't have any other class, so usually I think most probably I'll be finishing by 3. So 3 means I'll stopping at say 2:45 or something for the next previous class. So yeah, we can start with 3. If all are okay with that, no issue. Oh, ඉවරයි. ඊට පස්සේ නම් අවුලක් වුණා. මේකට අපිට මේ මොනවාද මේ මැෂින් එක නෙමෙයි. මේක දාගෙන බැරිද? පුළුවන් නේ. මේක දාගත්තා නම් එතකොට දා මොකද මේ එක්සල් එකේම වැඩ කරන්න බෑ මේකේ. දැන් අර මේකේ තියෙන කීබෝඩ් එක වැඩ කරන්න බෑ. මේක සප්පට දාලා මේ කරන්න බෑනේ. ඒක සෙට් එකක් එහෙම ඉන්ටර් කරන්න බෑනේ. එහෙම ඉෂුව එකක් තියෙනවා. එතකොට බලමු එහෙම වුණොත් මේ පොඩි වෙන නිකන් USB එකක් ගහලා කියනවා. මොකද දන්නවද? ඩිරෙක්ට්ලි අපි මේකට දාන්න ගියාම මේක තව තුනක් අපරාධනේ. එතකොට මේකේ දාන්න ඉබාට එතකොට අපිට ඒ වයර් එකට දාන්න පුළුවන්.